zoom in a little bit here, would be high d low minus low d high all over the square of what's below. Okay, what does that mean? That means I'd have g times the derivative of f minus f times the derivative of g over, what is that, f squared. Okay, that's the quotient rule. We'll get some practice with that today. The derivative of e to the x, of course, is itself. And the derivative of e to the kx is e to the kx times k. Alright, some of these rules we'll get more into as we go here. Alright, let's find the derivative of these four. Why don't you try these four and then come back and see what we got. Okay, so some of this is a mess, but I'll go ahead and do this here. Product rule, derivative of the first times the second plus first times the derivative of the second. Combine like terms. I get that. This is probably the most reasonable problem on this first four examples here. Here, this is actually foiling. Here's my first function, here's my second function. They're the same, so the derivative of the first times the second plus the derivative of the second times the first. Combine like terms, I get 50x minus 80. This is where some of the algebra can become cumbersome. Okay, derivative of the first is this times the second, right? I'm not going to go any further and expand that, but that's what the first portion would be. Derivative of the first times the second. And then we're going to take the first times the derivative of the second. And if you wanted to go further and simplify, you could. I'm not. Quotient rule. So low times the derivative of the high function minus high function times the derivative of the low function. That's a negative symbol there. All over the low function squared. Okay, so there's more I could go further with that, combine like terms and all that stuff, but I ran out of space. Okay, so let's go down here and let's pick. I'm gonna do number 6 and number 7. So I'm gonna go ahead and just do number 6 on camera here. Okay, so I got two functions. The first function is x, and the second function is e to the 5x. So product rule would tell me derivative of the first, which is 1, times the second, plus the derivative of the second times the first. So the derivative of this is going to be 5e to the 5x. So that's the derivative of the second times the first. So I should get that. And if you wanted to, you could go a little further with it and combine this. But it's totally not necessary. But that would be the derivative in this y notation right there. Okay, let's move on and find the equation of the tangent line to f of x, this function, at 3/5/4. So I'm going to go ahead and write this. I already know a point on this line, so I'm going to write this part, and I'm just going to leave a spot for the slope. So all I'm looking for is the slope of this function at x equals 3. Okay, so here is the quotient rule for y prime. So if I want y prime of 3, I'm going to plug a 3 in each of these places for x. And let's simplify. So this term right here would be 6 times 8, which is 48. Okay, this term right here would be 10 times 6, which would be 60. This term right here would be, it looks like 9 minus 1, which is 8 squared, which would be 64. Therefore, y y prime at 3 would equal 48 minus 60, which is negative 12 over 64. I'm going to do a little reducing. Number that I know that goes into that is 4, so it'll be negative 3/16. Okay, so our slope here at x equals 3 would be negative 3/16. And there's the equation of our tangent line. That's the equation of our tangent line to the function x squared plus 1 over x squared minus 1 at that point 3 comma 5/4. Okay, let's try another AP question here. What is the slope of the line tangent to the graph y equals that at x equals 1? So I don't have to come up with the equation of line, just the slope. So y prime, keep forgetting, y prime would be low d high. D high, be careful, negative e to the negative x, minus high d low, e to the negative x, times 1, right, derivative of the bottom, over x plus 1 squared. So if I want y prime of 1, I plug in a 1 everywhere that I see in x, and we simplify. So y prime of 1 would equal 2 times negative e to the negative 1. So 2 times negative e to the negative 1 minus 1 times e to the negative 1. All over, that'd be 2 squared, which is 4. Let's simplify this a little bit. So that would be negative 2 minus 1, which is negative 3. E to the negative 1 over 4. If I change this to a positive exponent, that'd be negative 3 over 4e. Looks like B is our answer. So you got to be careful. You know, you might have the right answer just in the wrong form. So be careful with your answers. And check, especially if they're multiple choice. You got a nice guide there. Okay, this is a really cool problem. Off camera, I'm going to go ahead and find the derivative of f of x real quick. Okay, so you can work your way through that if you want to, but I see that f prime of x equals 2 over the quantity x plus 2 quantity squared. So I want to find what point or points on the graph of f have the property that the line tangent to that equals 1/2. So basically what I'm looking for are the points that would make the following true. Okay, I want my derivative to equal 1/2. Okay, so you could do this a couple different ways, but what I'm going to do is I'm going to cross multiply and solve. So if I cross multiply, I get the following. And I'm going to go ahead and expand that. That's x squared plus 4x plus 4. And then I'm going to simplify. Wherever this is equal to 0, our derivative should be 1/2. So to me, it looks like 0. Let's factor out an x. That leaves me with x plus 4. That tells me that when x equals 0 or x equals negative 4, I should have a slope of 1/2. Now you're probably saying, well, you didn't verify that it was 0, 0 and negative 4, 2. Well, you could go right ahead and do that relatively easily. If I plugged a 0 in here and here, I get 0 over 2. So that checks. I could also plug in a negative 4 on the top and bottom. Negative 4, negative 4. That'd be negative 4 over negative 2, which is 2. That checks as well. Okay, another example, let f be the function defined by that. Okay, where k is a positive constant, find the first two derivatives. Okay, the derivative, just so you're aware of natural log of x is 1 over x. So let's find those first two derivatives. I'm going to do that off camera. Just as a hint with the square root, I would put that as x to the 1/2 power before you move forward. So there's our first derivative. If you take a look here, I rewrote as k times x to the 1/2 minus natural log of x. The derivative would be k times 1/2, which is k over 2, x to the negative 1/2 minus 1 over x. Now I'm going to rewrite. Okay, so I went ahead and used the power rule on the following. I changed square root of x to x to the 1/2. Got this as my derivative. Just did a little bit of simplifying, changing 1 over x to x to the negative 1 to help me with the power rule on the second derivative. So taking 1 away from this, I get negative 3/2. When I bring that negative 1/2 in front, it becomes negative 1/4. And then this x to the negative first makes the term positive when I multiply the two negatives, and then brings this to a negative 2. Therefore, I could rewrite with positive exponents in the following way. That would be the first derivative and the second derivative. Since this is free response, either of these would be acceptable. If it was multiple choice, I'd look for either or. Okay, I'm going to go ahead and work this second example, example 11 again off camera, and I'll come back and explain. Oh my gosh, actually I wanted to do this one on camera now that I relook at it because everything is pretty much given. Okay, in order to write an equation, I need a point and I need a slope. Well, I have a point. That point is 4, negative 3, given right here. And the slope I'm going to get directly out of that. So I'm going to plug x equals 4 into that, and that'll give me my slope. So h prime of 4. If I plug that in, I plug it directly into these three spots. So that gives me 4 squared, which is 16, minus 2. Oh, I didn't need to plug one in there. Scratch this piece. I don't need to plug anything in there. And then I need to divide by, looks like 4. So 16 minus 2 is 14. 14 fourths reduces down to 7/2. So the derivative, or the slope, on that function at x equals 4 is 7/2. So the equation of this line would be y plus 3 equals 7/2 x minus 4. There's the equation of the tangent line to the graph h at x equals 4. Alright, here's another AP problem. So let's go ahead and jump into this one. Okay, so for part A, I'm going to go ahead and show that it's continuous at x equals 0. What that means is I have to show f of 0 exists. The left and right hand limits are equal, and f of 0 equals the limit coming from both sides. Okay, so what I'm going to do is I'm going to take and I'm going to show that the left hand limit at x equals 0 is equal to the right hand limit at x equals 0. Okay, let's see here. So this would be 1 minus 2 times sine of 0 is 0. And here this would be e to the 0. And 1 minus 0 is 1. And e to the 0 is also 1. So check. F is continuous at x equals 0. I didn't really prove that f of 0 exists, but right here, if I plug 0 in, I really did. I showed that it existed right here, because that is f of 0. Okay, part B. Part B asks for x not equal to 0. Express f prime as a piecewise function. So f prime, why would it say not equal to 0? Because it's not going to be differentiable at that spot at x equals 0. So what would the derivative of the left side be? Okay, I don't think you know that yet. Okay, let's just look at the right side for right now, and I'll show you the left side in a second here. Well, the derivative on the right side, or greater than 0, would be negative 4e to the negative 4x. That would be the derivative of this function if x is greater than 0. Okay, and you don't know